Hello everyone, and welcome to today's chem lesson. Today we are going to wrap up our discussion on ions in solution by looking at colligative properties. Colligative properties are the properties of water that are changed when ions are present, when dissolved substances are present. Right? Regular water has a boiling point of 100 degrees Celsius. Salt water has a different boiling point. Sugar water has a different boiling point. Right? And that's because of the presence of those dissolved substances. We are going to focus our attention on two different properties. We are going to look at boiling point, and we are going to look at freezing point. Now, take a second and make a prediction. What do you think is going to happen to the boiling point and freezing point? Are they both going to increase? Are they both going to decrease? Is one going to increase while the other decreases? How do you think the presence of ions is going to affect these properties? You got a prediction? Fantastic. Let's actually look at what happens. We're going to look first at freezing point. And now freezing point is going to decrease if there are ions present in solution. Why? Well, think about it. What needs to happen for a cup of water, a glass of water, to become a solid? Those water molecules that are floating around need to go and form orderly rows and columns, right? They need to go into this substance. They need to become a block of ice. They need to make those rows and columns. If there are ions, these little red dots, if there are ions in the water, if there's an electrolyte in the water, if there's a dissolved substance in the water, then the water needs to form those nice orderly rows and columns and also move the ions out of the way while it does that. Right? There's an extra step when water freezes with ions present. Not only does it need to form those rows and columns, it needs to get those ions out of the way. And the fact that it has to get those ions out of the way makes it just that little bit harder. So you need to cool it down even more in order to make this substance freeze. Alright, so freezing point is going to go down if there are ions present in the water. Always, every time. What about boiling point? Boiling point goes up. It gets harder to boil the substance as well. Now I hear you're saying, Mr. M, but Mr. M, we just said it got colder, right? We had to make it colder because freezing was harder. Why does it go up if we're boiling it now? Why does boiling point go up? And that's because, think about what you're doing when you're boiling. You're putting energy in to make the substance boil. We're putting energy in to force these water molecules out of the liquid phase and into the gas phase. If there are ions present, those ions get in the way, and it makes it more difficult for the water molecules to escape. The water molecules bounce off of those ions, right? They can't get around all those ions. It's harder. And on top of that, remember that the water molecules are attracted to the ions. The positive hydrogens are attracted to the negative ions. The negative oxygens are attracted to the positive ions. So not only do we need to separate the water molecules from each other, we also need to separate the water molecules from the ions. We need to put more energy in order to make those water molecules boil, in order to make those water molecules leave. So because we need to put more energy in, the boiling point is going to increase. The boiling point is going to go up. No matter which one we're doing, whether we are freezing or boiling, having the ions present, having those electrolytes present, having those dissolved substances present, makes the process more difficult. So you need to go further than you would normally go. If we're freezing, you need to cool it down even more. Freezing point goes down. If you're boiling, you need to boil it even more. Put more energy in. Boiling point goes up. Now, does every substance have the same melting point, the same boiling point, the same freezing point if it's a solution? No. Again, the concentration of ions comes into play here. The more ions that are present, the better of an electrolyte something is, right? Remember that from 2 videos ago? The better of an electrolyte a substance is, the bigger of an effect there is on this colligative properties. All right, if we pull aluminum sulfate, this makes 5 ions versus calcium chloride, that makes 3 ions versus sodium chloride, that makes 2 ions. If I'm trying to freeze or boil a solution, a 1 molar solution of each of these things, the one with the most ions has the highest boiling point and the lowest freezing point. The most effect on this comes from the thing with the most ions. The biggest change to boiling point, the biggest change to freezing point, comes from the substance that has the most dissolved ions. Let's do one practice question. A 0.1 molar solution of which of these 4 things has the lowest freezing point? Lowest freezing point. I know what you're thinking. You're thinking, Mr. M, well, this is easy. C12H22O11, that's so many ions. That's gotta be the answer. But, actually, the answer here is choice 4, and we're going to talk about why. Remember when we talked about counting ions, we talked about making sure that you don't fall for the trap. Make sure you don't fall for the trap of thinking that covalent compounds break apart into ions. Covalent compounds do not break apart into ions. Look at all these C's, H's, and O's. It's a dead ringer for something that is a covalent compound. When you dissolve a covalent compound in water, you do not get it to break apart into ions. This dissolves in water and makes one thing. This dissolves in water and makes one thing. This dissolves in water and makes one thing. This dissolves in water and makes 2 things, because it becomes Na plus and OH minus. It becomes 2 ions. 2 dissolved things is greater than one dissolved thing, making choice for our answer here. Before we're done for the day, let's talk about icing the roads. Why do you buy rock salt, right? Why do you ice the roads in the winter? Why do you make sure to put that salt down instead of something like sugar? And here, if we use a sugar, right, it doesn't really matter what sugar I pick. Let's look at glucose. Glucose versus salt versus other salts, right? When you put sugar into the ice, if I were to go out on the sidewalk in the middle of winter and start sprinkling sugar down, it would lower the freezing point. It would absolutely lower the freezing point of the ice, making it melt. But it gives you one dissolved thing. Whereas if we use an ionic compound, they're going to break apart into ions and be better at doing what the sugar is doing. Right? 3 dissolved things per mole, that's way more effective than 1 dissolved thing per mole. You get the same effect much quicker when you use salt. If we're using the same amount of each thing, the freezing point is going to drop more drastically for the best electrolyte that's there. Right, so this would have a freezing point of -2, let's say. This would have a freezing point of -4. This would have a freezing point of -6 degrees Celsius. The more dissolved ions, the more dissolved things there are, the greater the effect on the boiling point, the greater the effect on the freezing point. The calculation itself, right, being able to say, well, there's 3 dissolved things, so it's -6. It's not actually -6, I just made that number up. But the calculation that you do to get the actual freezing point is more of an AP or advanced chem topic. Right? We can absolutely calculate what the freezing point would be for each of these things. We can actually compare those values, and it would be in this order, right? We would have this being the greatest effect on the freezing point. But the actual formula that you use, you don't need it. You're not going to need it for any of these things. You just need to be able to compare the identities of the substances. Which one of these is going to have the biggest effect on melting point? Which one of these is going to have the biggest effect on boiling point? It's going to be the best electrolyte, the thing that makes the most dissolved ions, the substance that makes the most dissolved ions. And that is all I have for you today. And I just want to make sure that everyone goes out there and has a fantastic day.